Sometimes you'll want to add fractions where they don't have the same denominator. So adding fractions, and this is where it can get quite interesting. So say you had the fraction 2 over 7 in red, 2 over 7, add, let's say, 2/3 or 2 over 3. Now here it's quite difficult because you're thinking, well, how do I add them? Because one is 2 over 7, one's 2 over 3, so I can't just add it together to get 4 over 7 or something. It's going to be more difficult than that. And the thing to look for is try to find what the denominator, I'll write this in this colour, try to find what the denominator, which is the bottom numbers, have in common. Try to find what the denominators have in common. So in this case, the denominators are 7 and 3. Let me just underline 7 and 3 because they're the bottom numbers. So what do they have in common? Well, they don't have each other in common. So if the 7 was a 6, then they would both have 3 in common. So the 3 could go into the 6 neatly, but 3 doesn't go into 7, so they don't have 7 in common. Do they have perhaps 14, which is 2 times 7? Well, no, because the 3 doesn't really like 14, it can't go into 14. How about 15? Because the 3 likes 15, it goes into 15 5 times. No, because the 7 doesn't really like 15. Now, how about 21? Well, 7 times 3 is 21, and 7 times 3 again is 21. So they both like 21. They both fit into 21. So we would have something over 21 plus something over 21. Now that is a lot easier to do, it's a lot more simple to do, because then you simply add the two different unknown elements. So if 2 over 7 is added to 2 over 3, what is 2 over 7 as a number over 21? Well, that's the interesting bit. So we have 2 over 7. Now, would you agree with me that 2 over 7 is this 2 over 7 equals 4 over 14? Because what I've simply done is I've multiplied the top side and the bottom side by 2. And when you multiply the top and the bottom side by the same number, the fraction stays the same. So 2 over 7 equals 4 over 14. Now the one further step is, instead of multiplying it by 2, I'll just put that in brackets so you see what I've done, times by 2. This time I'm going to times by the original fraction by 3, top and bottom. And that equals, if I just extend this a bit, that equals 6 over 21. So you've noticed I've got 2 over 7 into a number over 21 because I knew that 7 goes into 21 3 times, so I multiplied the top and the bottom by 3. Now the same with 2/3. We know that 3 likes 21 because it goes into 21. So 2/3. And can you guess what number I'm going to have to multiply the top and bottom by? Well, we know that to get 3 to 21 we have to multiply by 7, and we know we have to multiply the top and the bottom by the same number. So what we just do is multiply top and bottom by 7, and we get 14 over 21. So now we have a new thing to add. Instead of 2 over 7 plus 2 over 3, let's go back to red, we have 6 over 21 plus 14 over 21, and that just equals 20 over 21. So let's try that out with one more fraction. This time we have 4 over 18 plus, say, plus 1/2. Plus 1/2. Now, this time we're looking for what 2 and 18 have in common. Well, 2 goes into 18, so all we need to do is change the 1/2, because if we're trying to look at what the denominators have in common, well, 2 does like 18. 2 does go into 18. So all we have to do is change the 2 to get into the 18. So that 1/2, now can you guess what number I have to multiply the top and the bottom by to change that fraction into something over 18? It's 9. So we're going to times top and bottom by 9, and we get 9 over 18. 1/2 is the same as 9 over 18. So now we have a new equation, a new thing to add, which is 4 over 18 plus 9 over 18, which now equals 13 over 18. So what looked like a hard fraction to add up, actually, when you find out what the denominators have in common, becomes quite easy.